Hi, my name is Daniel Vargas, and I am in the Geology 111 section, class O3. And I will be today talking about the geological history of Mars, the corresponding uh, Jericho crater, not Jericho, Jezero crater, and the types of sedimental rock that we expect to find in this particular dispositional environment. So, Mars formed a long time ago around the formation of the Earth, but some things, key points about Mars that are different from Earth that I think are really elucidating of why Mars is the way it is now as opposed to Earth is Mars is further from the Sun. Mars also is much smaller. It's about half the diameter, with about 11% of less of the mass of Earth. It also has a solidified lithosphere, so it's a much more rigid body, which led to it be geologically stagnant because there's no tectonic plates. It had early volcanic activity because of hot mantle plumes, but after it cooled, while it does also continuously still have radioactive decay, which is about 80% of the heat that is generated in the Earth today, not from its initial event. Because of its size, of Mars' size being smaller, it has less of that radioactive material. It also has a less way of recycling that heat through tectonic plates because it doesn't have tectonic plates because it's a little side sphere, because it's further and it has less material to work with. It also has a lot less presence of water. It has a lot less presence of water because of that solidified core, which stopped the dynamism of the core, which prevented it from having a magnetic shield to shield its water in its atmosphere. And that water really serves serpentine, particularly whatever in our core or in our tectonic plate serves as to a lubricant to heal, or not to heal, to assist the melting and therefore the movement and the convection currents that our tectonic plates have, which Mars does not. From that history and a bunch of those factors, which lead to Mars to have a solidified core, we can talk about the particular rocks that are found in the Jezero crater, found by Serena. There are two types. There's sandstone or mud sandstone, and then there is mud. Those two rocks, mudstone and sandstone. And the reason those rocks are important is because they indicate the presence of water. Water flowing particularly in a low energy environment. Mud stone will be deposited over time, like over on lakes, where they'll accumulate in crater layers, and then sandstone or mud would be created by sand from river deltas or shorelines. And if there was a delta, which was what we'd expect in the Jezero crater, that would be the rocks that would be evidence there. And to address the third final question, we have that we would expect these rocks to be in this particular environment because we expect that this Jezero crater was a river delta, and these rocks would be carried from other places and then deposited there because of their particular grain size, which allowed this low energy to carry. Because the low energy stream could only carry so much, it would be only carrying those type of sediments there and depositing them there.